Hello everyone, I am Abhishek Datta and you all are watching my YouTube channel Mathematics Made Easy. Today I am here to discuss about the concept of matrices, which is a very important vital concept to study higher mathematics. So basically matrix and determinants, these two topics are correlated to each other and they have their vast applications in various sciences, particularly in the study of engineering. So what is a matrix? By a matrix, basically we shall mean an arrangement, a rectangular shaped arrangement of certain objects. So let me illustrate the same with the help of a diagram. So let us consider some alphabets. We want to arrange some alphabets in a rectangular fashion. So rectangular fashion means we have to arrange them in certain rows which are horizontal lines and in certain columns which are vertical lines. So say we have some alphabets A, D in any order, not necessarily in alphabetical order, A, D, E, F, then say G, H, I, O, then P, Q, R and S. So here we have some alphabets which are arranged in some horizontal lines. These lines are known as rows, and also some vertical lines. These lines are known as columns. So they form a rectangular shape. If we join the perimeter, we are getting a rectangular type arrangement. So such a rectangular type arrangement is said to be a matrix, and usually we enclose these elements within a first bracket like this. This is the symbol of a matrix. Instead of first bracket, you may also give a third bracket. This is also the symbol of matrix, or you may use double lines. This is also used to represent matrices, any one of these. Usually in Indian books, these two symbols are used. In foreign books, you can find this symbol for matrix. So either we shall be using the first bracket or third bracket to represent a matrix. So basically matrix stands for an arrangement, a rectangular arrangement of certain objects in some rows and in some columns. And the objects are termed as the elements of the matrix. So here A, D, E, F, each of these alphabets are the elements of this matrix, and we represent the entire matrix by some capital letters, say A, B, C, like this. Whenever we have to name a matrix, we shall use a block letter, a capital letter. Now these elements may not be alphabets, they may be numbers also, or they may be real world objects also. That is, if we arrange some chairs, say in certain rows and also automatically in certain columns, then that rectangular arrangement of those chairs also give us a matrix. In a class, the sitting arrangement of students in successive benches, they also form a matrix if you consider the benches to be rows. So we have a rectangular shape arrangement. So those sitting arrangement of students also forms a matrix. So the elements of a matrix may not always be mathematical. That is, they may not be numbers or they may not be alphabets. They may be real world objects also. Next is to define the order of such a matrix. So what we mean by order of the matrix? By order of a matrix, we mean the number of columns multiplied by the number of rows. A number which is expressed as, it is a pair of numbers expressed as number of rows multiplied by number of columns. Let me explain this. As for this example, for this matrix A, we have 3 rows, first row, second row, third row. The rows are counted from top to bottom and we represent them by the symbols R1, R suffix 1, R suffix 2, R suffix 3. That is first row, second row, third row, and the columns are counted from left towards right, and we represent them as C1, C2, C3 and C4. So here this particular matrix contains 3 rows and 4 columns. So the order of this matrix is given by the pair of numbers 3 into 4, whereas the left hand number 3 shall represent the number of rows and the right hand number 4 shall represent the number of columns. And to represent the order, we can write the order here in the bottom right corner of the matrix, 3 into 4. Although we are writing 3 into 4, while reading the order, we read as 3 by 4. Likewise, we say the measurement of a room 18 by 20 feet. So actually it is 18 into 20, but while reading the order you call it 3 by 4. So here A is a matrix of order 3 by 4. So if the order of a matrix is known, from here we have three informations about the matrix. First of all, the number of rows the matrix contain. Likewise here the matrix has 3 rows. The number of columns the matrix contains, it has 4 columns, and also the total number of elements which the matrix has. Likewise here the matrix has 3 into 4, that is 12 number of elements. If you count them, here we have 12 number of elements. So when an order of a matrix is known, we can know the number of rows of the matrix, number of columns of the matrix, and also the total number of elements of the matrix. Now we can name a matrix as per its shape, that is types of matrices. We can have various types of matrices. Let me discuss a few. First type is a rectangular matrix. As the name suggests, by a rectangular matrix, we shall mean a matrix where the number of rows and the number of columns differ. So it will have a shape of a rectangle, as we all know that the length and breadth of a rectangle are not equal. So rectangular matrix means a matrix where number of rows not equal to number of columns. For example, if I consider a matrix A, say 1, minus 1, 2, 3, 1, 4. So as we can see, it has 2 rows and 3 columns. So the matrix has order 2 by 3. So number of rows and number of columns are unequal. So it forms a rectangular shape. So such a matrix is known as a rectangular matrix. Obviously the next one should be a square matrix where the number of rows and number of columns should be equal. So that is the next type, square matrix. That is, if I add in some elements in equal number of rows and columns. So here number of rows becomes equal to number of columns. That becomes equal to number of columns. That is a square matrix. For example, if I form a matrix B with 2 rows and 2 columns, say 1, 2, 4, minus 5. So here we have exactly 2 rows and 2 columns. So such a matrix is said to be a second order matrix, or a 2 by 2 matrix, or a square matrix. Similarly, it may have 3 row, 3 columns, 4 row, 4 columns likewise. But wherever number of rows and number of columns are equal, we call it a square matrix. The next type is a row matrix. Row matrix. So as the name suggests that a row matrix is a matrix containing only one row. So a matrix having only one row, but more than one, it may have more than one columns, but it will have only one row. Then it is termed as a row matrix. For example, if I have a matrix capital C given by 3, 2, 4, 7. So here we see it has only one row. Now how many columns it has? It has 4 columns, 4 vertical lines. We have only one horizontal line but 4 vertical lines. So the order is given by 1 by 4. That is the order of the matrix. 1 by 4. It has one row but 4 vertical lines of 4 columns. So such a matrix is a row matrix, a matrix having only one row. Similarly, we can also have a column matrix. That is a matrix having only one column. Likewise, if I have the same matrix C in vertical fashion, 3, 2, 4, 7. So now as you can see that here we have 4 horizontal lines but only one vertical line. So here we have 4 rows and 1 column. So order is given by 4 by 1. So this is a column matrix. Here we have a row matrix. Next is a null matrix or a zero matrix. So as you can already understand by the name that by a zero matrix or a null matrix we mean a matrix whose all elements are 0. A matrix whose all elements are 0. Now here by 0 I may not necessarily mean the real number 0. It may be 0 vector. If I deal a matrix of vector, I mean a matrix whose elements are vectors, they may be all 0 vectors. They may be, if I deal a matrix whose elements are sets, then by 0 we mean the null set likewise. So this may not mean the real number 0. So whichever system we are dealing, 0 of that system. So if we have a matrix whose all the elements are 0 of a particular system, they may be null vectors likewise or real number also, then such a matrix is said to be a null matrix. A null matrix may be rectangular or may be square, so there is no certain restriction, but the main point is every element should be 0. Such a matrix is known as a null matrix. Next is idempotent matrix. Idempotent matrix. Now a matrix, say capital A, is said to be idempotent if you multiply A with the matrix A itself. We shall discuss how to multiply a matrix with the matrix itself in my later videos. For time being I am just discussing the definition that if you multiply the matrix A with itself, that is A into A, the result should be the matrix A itself. That is, in other words, we can say if A square is equal to A, then such a matrix is said to be an idempotent matrix. Now by A square I don't mean the square of the elements of A, that is not so. Say for example, if A is the matrix 1, 2, 3, 4, A square is not simply squaring these elements, it is not so. This is to multiply the matrix A with the matrix A itself. We shall discuss the rule of matrix multiplication in my later videos. For time being, you consider that A square means A into A, not squaring the elements. Now if the result gives us the matrix A itself, if we get back the matrix A itself, then such matrices are said to be idempotent in nature. So these are some types of, few types of matrices. We also have some more types of matrices like symmetric matrices, Q-symmetric matrices, diagonal matrices, likewise orthogonal matrices. I shall be discussing those later on. But before that, let me now discuss a particular operation on a matrix known as a transpose operation, because this particular operation you should know before discussing symmetric matrices, Q-symmetric matrices or orthogonal matrices. So what we mean by transpose of a matrix? Transpose operation on a matrix. So by transpose of a matrix we simply mean by interchange, we simply mean interchanging of its rows and columns. So for example, if we have a matrix A given by -1, 2, 3, 4, 6, 7, and as we can see it has the order 2 by 3 because it has 2 rows and 3 columns. The transpose of A is represented by A dashed, that is the symbol for transpose, A dashed. Some author also use the symbol AT for transpose, AT or A dashed. So this is another matrix which should be formed from A by interchanging its rows into columns. That is, we now write the first horizontal line as the first vertical line. So we are making the first row into first column, and similarly the second horizontal line should be written along the second column, that is the second vertical line. So automatically the columns of A becomes rows of A dash. The first column becomes first row, the second column becomes second row, and the third column becomes third row. So as a result, the order of A dash should be exactly the opposite, 3 by 2, because now it has 3 rows and 2 columns. So this is the transpose of the matrix A. So whenever we apply transpose operation on a matrix, that means we simply interchange its rows and columns. And as you can all guess very easily from here, that if I again apply the transpose operation on A dashed, that is A transpose transpose, automatically we shall get back the matrix A itself. That means if we again interchange the rows into columns, we shall get back the matrix A itself. So double transpose gives back the matrix itself. In fact, if I apply the transpose operation an even number of times, that is A transpose, whole transpose, again whole transpose, likewise an even number of times, that will give back the matrix A itself. And if we apply the transpose odd number of times, the result will be A transpose itself. So this is the transpose operation on a matrix. So with the help of the transpose operation, we can now discuss about symmetric matrix. Symmetric matrix means a square matrix. The next type of a matrix is symmetric matrix. So symmetric matrix means it is a square matrix. The matrix should be a square matrix. We must have equal number of rows and columns. So it is a square matrix, say capital A, whose transpose coincides with the matrix itself. If A transpose becomes equal to A itself, then such a matrix is said to be symmetric matrix. For example, if I consider a matrix A, say 1, 2, 3, then 2, 4, 7, 3, 7, 9. So it is a square matrix of order 3 by 3. And if I now form A transpose, that is A dashed, we write the first row as first column 1, 2, 3, write the second row as second column 2, 4, 7, and make the third row as third column 3, 7, 9. So as you can see that there is no changes in A dashed and A, we get the same matrix itself. So here we have A equal to A dashed, they are exactly identical. Then such a matrix A is said to be a symmetric matrix. So here these are some few types of matrices and the transpose operation on a matrix. In my next video, I shall be discussing some more types of matrices and some more advanced theory on them. I hope this video is helpful to you, and you can ask any doubts if you have in the comment section. Thank you all for watching the video. Have a nice day.